Today I want to talk about programming in mechanical design. Let's look at a couple of functions that we've encountered in mechanical design. First of all, we have an independent variable alpha, and we have a beta dependent variable that's a function of alpha. So we'll program that. Then we have a third variable, a dependent variable gamma, that's a function of both beta and alpha. We're going to look at how these things vary when alpha spans from 0 to 2. Let's look at three different languages. Let's look first at Excel, that relies on Visual Basic for applications. Let's look at MATLAB. Let's look at Mathematica, the last two using UF apps. Okay, let's take a look first at Excel, and I'll do the first column. I'll set myself up for an alpha, second column for a beta, the third column for a gamma. And I'm going to take a look a little bit more than 0 here. I'm going to start my alpha at 1/16, and then I'm going to let the remaining entries be the previous one plus a 1/16, and then I'm just copying this down. I should have about 32 of these or so to get to 2. I need one more. Okay, so I've kind of got my alphas all squared away. Well, now I'd like to set my sights on the beta and gamma that corresponds with each alpha. I could enter in actual formulas here into the formula cell, but I'd like to show you how to do some programming here. So let's go write a get beta function, and to do that, what I do is I go over to developer, and then I go to view code, and then I come here to the VBA project for this book. I go right mouse, and then I say insert module, and then in that module I'll come over here, and then I'll insert a procedure and actually a function. I'll give it a name. I'll call it get beta and make it public. Okay, so now I have my function there, and I want to give it an argument which will be the alpha. Locally, I'll call that variable A, and I want to declare A as a double. Okay, so the function here, I'm going to say get beta, so that would be the actual answer or what the function returns. Get beta will equal, and then I have to kind of remember what the function is. Well, I could bring up my PowerPoint here real quick and see that beta equals 1 plus 4 alpha squared in the numerator divided by 4 alpha in the denominator. So let's do that. Open paren 1 plus, and again I'm looking at A as my alpha here. 4 times A caret, so the caret is the exponential function. So A to squared, and then I want to divide that by 4A. Note the use of parens here, and I'll end that with a semicolon. So that should be good. Oh, why doesn't it like that? Let's take away the semicolon. Okay, so this one doesn't use a semicolon to terminate the end of the statement. So it's spread it all out, so it's accepted it. Let's go back into the Excel file. Now I want to see if I can actually use it. So I'm going to, under the beta column, I'm going to select that first cell and I'm going to say equals. Now I should be able to type in get beta. See, it's already there. It's already telling me, hey, it's there. So I go ahead and accept it. Now I'm going to use as the argument, I'm going to use this cell A2. So that should be correct. I close it, close paren. And so the beta that corresponds with alpha will be the alpha point of 1/16. That beta would be 4 and 1/16. Now when I take that cell, copy it, and paste it into the next one, it's automatically changed the reference for that row of beta to correspond with that row of the alpha. So it's gone from A2 to A3. So this should be the beta, the 2 and an 8th will correspond to the 8th of the alpha. And what I could do is just simply paste the whole column and I'll have it. Alright, so let's take a look at a couple here. Well, when alpha is a quarter, we're going to have beta as 1 1/4. So kind of remember that. Okay, so that's my get beta. Let's go try to do the same thing for gamma. So where is my code? Go back and find my code. Here we go. Alright, I'm going to go a couple of lines down, and then I'm going to insert another function, and I'm going to call this one get gamma, also public. And then here I'm going to have A, my argument's A as a double, and I'm also going to have B as a double. So what I'm doing here is inside this function locally, A is going to play the role of alpha and B is going to play the role of beta in order to calculate what gamma is. So what the function is going to return, you have to set a variable, get gamma, equal to something. Let me go back and refresh my memory what the heck gamma is. Okay, it's beta to the 4th, in the numerator, beta to the 4th minus, then I have a beta minus 2 alpha quantity to the 4th, and then I divide all that by beta. So let's go put that in. So I should have B, and the role here is B to the 4th minus, and then I'll have a B minus 2 times A, and that is to the 4th, close parens, and then I'm going to divide that by beta, or locally it would be B. Okay? So that should do it there. And in this language, don't need the semicolon that I tried to put earlier. Okay, so I'm looking good there. So when I go back into my spreadsheet, I should be able to select that cell and then say equals get gamma. So it's already there, get gamma. And I'm going to say for my A or my alpha, I'm going to select that cell. I'm going to put a comma. And then I'm going to select that for my B or my beta. And the answer is 7.87 for that row. Again, take that, copy it down. And I have them all. So let's go take a look at, just as a point of reference, when alpha is a quarter, I've got beta as 1.25 and I have gamma as 1.7. Remember those values. And it looks like I've gone 0 to 2 on the alpha, and so I have the corresponding beta and gammas. Now what I'd like to do now is to actually plot this. So what I could do is go to insert, and I want to plot beta and gamma. Well, first of all, let's plot beta as a function of alpha. Let's do that. So I'll select those two columns, and if I were to select line, it actually wouldn't give me what I want because it's going to plot alpha and beta against basically nothing. I want beta as a function of alpha. So to get that, it's really it's kind of bizarre, but I use the scatter, and I believe that's the only option you have. So I'll use scatter, and that puts alpha along the x-axis and your beta along the y. So we're all good, and it even puts a nice legend in there for you. So that's how you would do that. Now if you wanted to plot, let's move this. Let's move the chart to being a new sheet. So it kind of takes over as a full sheet. Let's go back to the sheet. Let's say that I wanted to plot both beta and gamma as a function of alpha. I could select all three columns then, and then yes, just simply insert a scatter. Now I picked the one that has the smooth lines. So there you go. So now you have beta and gamma here as a function of alpha. And then you see the blue beta, how it goes. And then you have the red gamma, how it goes. And if you remember looking at the quarter alpha, that would put you at right about here. Yeah, you're looking at 1 1/4-ish for the beta, and you're looking at about 1.7 or so for the red gamma. Okay, so that's pretty cool. So let me go up here and save as. I'll save this. Just save this to my local hard drive. I'm going to call it temp. Book 1 and temp. Oh, here we go. Here's something that I forgot to tell you about. Save the files. No. Okay, so the particular type of file, the Excel, just a plain Excel workbook, won't let you do programming. So I need to be careful here. To save a file with these features, click No and then choose Macro Enabled File in the file type list. Okay, so I'm going to say No, and then I'm going to come down here and I'm going to select actually an Excel Macro Enabled Workbook, XLSM. So I select that, and then I have it just as a nominal Book 1 with that extension under my local hard drive temp. So I'll save that. Okay. Now what I want to do is I'm going to close this. Boom. And then I'm going to reopen it. Just to see if it's all there. Yep, sure is. Let's go look at the code. Developer, view code, module, and there's the code that we wrote. Now one final thing is here, obviously in a real program you would test for whether A is 0, because that can be a problem here, or B is a 0. So you do some sanity checks, but I'm just trying to get your feet wet as far as seeing, hey, local variable A, here's how you program it, and how it actually really, quite frankly, looks just like the functions that you're dealing with. It's very simple. So anyway, that's Excel. If you wanted to learn more about Excel programming, you could look up Excel VBA, maybe function reference, because there are some functions you can call there. Let's see what comes up. This is a good one, Tech on the Net. So here you've got some functions listed by category, and you can go in and see how to call them within the functions you write. So it's really good. Okay, now let's see if we can get into UF apps. So go apps.ufl.edu, username, password. Let's see what happens. So you have to have this Citrix receiver already downloaded, and I do. So I played around with it a little bit. So when I go to apps, first thing I want to show you here is this strange thing called an M drive. So come over here to the M drive. All the applications, at least the ones I've poked around in, they tend to want to use this M drive. So I'm bringing up the application maybe. Come on. Where are you, M drive? You're starting. There we go. Okay. So what caught me off guard a little bit on this M drive is it says this PC. That's not my PC. I don't know where this PC is, but it's not mine. I'll have a documents folder, and I've already kind of played around with the mic MATLAB file, and I have a temp mathematical file, so I know I can kind of do this. But this is not local on my computer. It's local, I guess, at UF. Now, if I want to get to mine, see if I can show you. My hard drive is Defiant, so that's called the local disk. So if I go there, and then remember I had in temp, I have that book 1. So yeah, that's my local. But this PC, like I say, I don't know where it is, but I'm not going to fight it. I'm just going to go with it. So I'll minimize that. Then I'm going to bring up MATLAB. Okay. So here's MATLAB, and it looks like MATLAB. Now, over here, in this window here, this bar, you want to set your M directory here correctly, and I'm going to choose Documents, and that's where I have that mic 1 that I was just playing around with, adding, seeing if I could just add a couple of numbers. So that's what I had there. That's not what I'm going to show you today, but at least you can see it. I'm going to call a new function. Let's call it get beta. And I want my input variable to be A. Output argument, I'm going to set that as B. Okay, then I'm going to let you fill in the summary of the function and that type of thing. But I'm going to say, refresh my memory here, what's beta? Beta is 1 plus 4 alpha squared divided by 4 alpha. Alright? So I'm going to say B equals 1 plus 4 times, 4 times A squared divided by quantity 4 times A. And I think I need my semicolons here. Let's see. Yeah, I don't think it likes it, so I'm going to put the semicolon in there on the end. So I think I'm good. Now it's labeled as untitled. I'm going to try to save it and see what happens. Yeah, it wants to save it as get beta. And then it comes over here in this directory that we're talking about. You see my mic, the original mic 1, and now I have beta, the get beta function. So the way MATLAB works is it wants to have the file name of your function be the same as your function name. Okay? So let's see how this works. If I come over here in my script window and I say, let's say get beta, and I'm going to use the quarter for the alpha, and let's see if that makes sense. Answer, 1 1/4. So yes, that looks good. Okay. I want to really define a whole array of alpha that spans from that, say, the 1/16 all the way up to 2 in 1/16 increments. So the way you do that is you say, for example, define alpha as 1 divided by 16, not 15, 16. That would be the beginning of the start of my array, and then I do a colon, and then I do my increment, and then I do my ending value as 2. So it goes start value, increment, and ending value, those three numbers separated by those colons. Let's see if I hit return if it likes it. So looks good. So yeah, it's showing me, I guess it looks like a row vector because it's calling out columns 1 through 32. What if I did length? Is it length? Alpha. Yeah, 32. Okay, so I've got my alpha ready to go. Now what I'd kind of like is just to throw that alpha at the beta and then have get beta, and then have my get beta function return 32 different values where they correspond to each of my alpha entries. Let's see what happens. Get beta, and then I'm going to throw it in that whole array. Inputs must be a scalar, so red is not good anytime you see that. Yeah, it's wanting me to compute element-wise, use the dot. So there's this dot thing going on, and I think that'll still work with the scalar. So what I need to do is I need to come back up here, and where I have the exponent operator, the caret, I need to put a dot in front of it. And also the dividing thing. So it goes element wise. The multiplication is going to be 4 times that array, so that's going to be okay. I don't need the dot there because it's a scalar. But it's the array. When you know, if I didn't have that dot, it would try to take that whole array and square it. So it's kind of goofy. So they put the dot notation to go element wise. Okay, so let me go and save that. Let me see if that makes sense now. So if I say get beta, I did the last command, and when I do get beta of alpha, I'm going to get 32 different ones. And remember, the first one starts at 4.0, 4 and 1/16 basically, and then the quarter value has that 1.25. So this looks right. So that's going to be my get beta value, and I can actually say beta equals get beta of alpha, and that gives me those 32 values. So if I say length of beta, I'm going to get 32. So that's looking good. Let's go do my gamma. How do I do that? I'm not the expert in this, by the way, but let me say new function. All right, and I'm going to call this one get gamma. My input arguments, I'm going to do the AB thing again, and I'm going to say, my output argument, I'm going to let that be gamma. I'll just call that G. Locally I'll call it G, so I'm going to say G equals. Let me go remind myself what it is. Numerator, beta to the 4th minus, and then I have a beta minus 2 alpha quantity to the 4th divided by beta. Come over here, I'm going to have B to the 4th minus, and then I'll have B minus 2 times A, that quantity to the 4th, close paren, and then I'm going to divide by B. MATLAB, so I need to end that with a semicolon. Then remember, I've got arrays coming in potentially, So I'm going to make this a exponential version of this and put dots in front of the exponents. Don't need it on the minus. Don't need it on the 2 times. I'm good there. I think I need a dot in front of that exponent and a dot in front of the divide. So that means component wise. I'm going to save that. It wants to save it as get gamma. I'm happy with that. So I've got get beta and a get gamma. So let's next go down here and use it in the command window. So I could say, just testing this out, I could say get gamma and then give it the alpha and the beta. See what happens. Looks like I did get the 32 result, 32 elements. Let me go ahead and say gamma equals get gamma alpha beta and return. Okay, so then I can say length of gamma to see if it's 32. Yes, it is. Let's go take a look at some of these values, particularly the fourth one, which is the 1.7, and that does agree. That is the gamma that corresponds to an alpha of 1/4 and a beta of 1.25. So it looks like we're kind of good here with these values. So have all that in my workspace now. If you look over here, actually, you can see your workspace. I've got so far an alpha that's a 1/32. I've got a beta that's a 1/32, and I've got a gamma that's a 1/32. So all this kind of makes sense. Now, what would be nice here if I could plot this. Plotting, again, I'm not an expert, but in MATLAB, I believe you say plot, and then you want to give it whatever is going to be your x value. It even tells you right here your x and your y. So I'm going to say plot alpha and beta. See what happens. Oh, there we go. So there's my beta as a function of alpha. When alpha is about 1/4, then my beta should be about 1.25. It should be kind of right in there. And that looks pretty good. All right. All right. I wonder if I can insert a legend. See what happens there. Oh, it shows it as data 1. I guess we could clean that up. Figure that out later. So that's plotting alpha and beta together. What if I wanted to plot both beta and gamma as a function of alpha? I think what I have to do is give a 32 by 2, 32 rows by 2 columns into the beta. Let me play around with this a little bit. Let me define a matrix M as concatenating an alpha vector, and then I'm going to put a tick on that with a beta vector, and a tick. So what this is doing here is it's going to take alpha. It's going with that tick. It makes it into a column vector, and it'll concatenate that with the corresponding column vector of beta. Actually, no, I want beta there. Dadgummit. I want beta there, and I want gamma there, because I want to put those two together. Beg your pardon. So we've got beta and gamma kind of glued together. Let's see what that looks like. Yeah, so M is coming through as a 32 by 2, 32 rows by 2 columns. So let's go sneak up here and take a look at what that fourth row is, if it'll cooperate with me. Yeah, so the first row has that 4 1/16 element entry there. So this column here is my alpha. The fourth element, fourth row should be 1 1/4 for the beta, and 1.7 for the gamma. So once again, your beta column here and your gamma column there. Now, let me go try to plot both of these. So I'll say plot, and then I'll say alpha, and I think M. See if this works. Okay, yeah, it does. So I've got the blue is going to be the beta, the red is going to be the gamma as a function of alpha. I can come back up here and insert legends and probably clean that up. So that's what that looks like. Now, so that that sort of gets us going. There's one more thing I'd like to show you. I'd like to show you how to kind of combine or put together all these commands, these various commands we had inputted into the command window. What I'd like to do is generate a script file. The first thing we did was define an alpha vector. So I'm going to do that. Just repeat a couple things here. Real quick, I'll put a semicolon on the end of that. And then I said beta equals get beta of alpha. And then I said gamma equals get gamma of alpha and beta. And then I said plot alpha. Oh no, need to redefine that M up here. I'm trying to set this up so the next time I come back in this program, I could just run this simple script file, and I would regenerate what I did here with you. So I want to re-enter all of the commands. So I think that's all the commands I had. Nope, dang it, I did that again. I want M to be beta and gamma, because I'm putting beta and gamma and gluing those together so that I can plot them with as a function of alpha. So I think I got that right. Then I'm going to save this as, I'm going to call it main.m, sort of like in C. We have a main function. So that'll be my script file. Okay. And yeah, so I've got, you see, I've got my get beta, I've got my get gamma, I've got my main right there. Now I want to clear this workspace. Let me show you. I could do a CLC, and that just clears the command window. Actually, it doesn't clear the workspace. I still have that kind of active over here. I think if I type clear, it'll clear that. So I have that all clear now. So I'm really starting over without having to relaunch all this. What I want to do is I think I just type main, and it'll run this script file, put everything together for me. Let's see what happens. It did. So it generated my whole workspace again. I've got the alpha, I've got the beta. They have the same size that we had before. And I've got that M, which is helping me plot. And here's my plot, same plot I had before. I can insert my legend, see what the colors mean. So data 1 is that first column of M, and data 2 is that second column. So that'd be the beta, and the gamma is a function of alpha. So that looks pretty good. Right. So I think that if I go home here, there should be a way to get help. So if I did that, just to show you, hey, if I wanted to get help documentation, I could go here and look at the documentation for all of the MATLAB functions and whatnot, some examples, support website. I think the documentation would be a main thing, so you can see what the functions are that you can use in MATLAB. So I think that pretty much takes care of MATLAB, just getting your feet wet again. And of course you want to go in and make these functions idiot-proof, so if you sent in a 0, it wouldn't blow up on you and whatnot. So anyway, so hopefully that gets you going on MATLAB. Okay, I wanted to show you also Mathematica, and it looks like it timed me out, so I'll log back in, go to Apps, come down here and find Mathematica. Let's go play around with that. While that's loading, I'll just bring up my M window here again, and I do have those MATLAB functions are here, the get beta, the get gamma, and then that main. So those things are there. Alright, so now I've got a Mathematica workspace. See, some of you know this. Let's get right to it. So I could type in function get beta, and I want my argument or my local value variable to be a again. And in Mathematica, if my local variable is a, I'll enter it as a parameter as a underscore, and the function parens are actually braces or brackets like that. So then I say colon equals, and then I give the definition. And remember that the numerator is 1 plus 4. I don't need the star for multiplication in Mathematica, so I put 4 space a, and then I have the square, and then I'll divide that by 4 space a. And then I'll end that with a semicolon. Hopefully that works. And in Mathematica, the way you enter a command is with a shift enter. So I put that in, and I'll hit shift enter. Okay, so it likes that. And what I can do is do the get beta of 0.25 to make sure it's all working. Yes, it is. It's giving me the 1.25, so I'm good there. Oh, we've got some suggestions. Oh, I love this. Kill that. Alright, so we've got that. Let me go ahead and type in a get gamma function. And locally I'll have the a underscore. The underscore is some syntax in Mathematica that says, hey, that's going to be a local variable. So I've got the a and the b both set up for my get gamma, and hopefully I get this right. I'll have a b to the 4th, and then I'll have a b minus 2 alpha, or a here locally, to the 4th. And then I'll divide that by b. I put the semicolon to end it. And then I'm going to do a get gamma of 0.25. And then I'll put get beta right there, 0.25, as my b, or my beta argument, or the b slot there. Okay, so I do a shift enter. And that's going to return 1.7, which is the value, the gamma value that goes with the alpha of 1/4 and the beta that corresponds with the 1/4. Just to remember, let me put that back in. Get beta of 1/4. So that's 1.25. Mathematica has a cute little function, or cute little variable. I think it's the percent sign, and the percent sign actually means the result of the last command, which would be get beta of 1/4. So this should be the same. If I hit shift enter, yes it is. So just playing around with that. What I could do is define an alpha as I want that whole array again. I want to start at 1/16, and I want it to go up to 2 and 1/16 increments. So I can, in Mathematica, I do that with what's called a table, and I'm going to define the table as I, the variable I that goes, and I will go from 1/16 to 2 in 1/16 increments. See if that's right. No semicolon, so I can see what it is. Shift enter. Yes, it is. So that's done it correctly. So in Mathematica, it goes starting value, ending value, and increment. So I've got my array for alpha all set up, starting at 1/16 and going all the way to 2, and the fourth one is the quarter. So now in Mathematica, I can just say beta. It's all set up. I don't have to worry about that preceding dot stuff. So I'll say beta equals get beta of alpha. You just have to remember the syntax here is the square brackets rather than parens. So let's see what I get with that. I'm getting the beta starts at 4 and 1/16, and the fourth element is 1 1/4, so I'm good there. And what I can do is say gamma equals get gamma, and then I can say the first argument is my alpha vector. Could be scalar. I could just do the one like I did before, but I want to do the whole arrays, both arrays, alpha, beta. And then my gamma will be an array. Starts at 7 and change, and the fourth element, is 1.7. So that's looking good. Now I want to plot. Let's see, I could plot. Let's see. I could plot. Let's do get beta. Get beta of A. Let me use A for a second here and see if I can remember how to do this. So the way plot works is I put the function I want to plot here, and then I put what will be the independent variable for the plot. It's going to be A. I'm going to go from 0 to 2. See if it blows up or what happens. Oh, well, there you go. So it's handled it. Mathematica's handled it. Yep, the 1/4 alpha is about 1 1/4. So that kind of works there. And I could do the same thing for get gamma. And then here I need to say get beta of A. That would plot my gamma as a function of alpha going from 0 to 2. Hit shift enter. And yep, there I go. I've got the gamma now as a function of alpha. And then what I could do is actually glue these together. If I start open bird wing, and I'm going to come up here and cheat a little bit and cut that one, put it down here. So I'm plotting multiple functions as a function of this independent variable A in this plot statement. So I've got open bird wing, the get beta, then I have get gamma as a function of that A. So plot that. So yeah, so I end up with both of them right there. Okay, what I'd like to do is to take the data that I had, the actual alpha, beta, and gamma, and kind of use that. What I could do is put together, say, an M1 matrix, and I want to kind of create that. Actually, let me do this. Beg your pardon. Let me start with a new command area. So I've got all these. I've got the alpha, the beta, and gamma all ready to go. Let me come down here and start with a little bit of a clean command window. So I'll say M1, define that variable. I'm going to define it as a transpose. Let me type it in, join, no, not join curve, join of alpha. And actually I need to put let me get it in, and then I can work on the syntax. Okay, so what I've got here is I'm going to take alpha and glue it together with beta, and I've put extra bird wings around the alpha and the beta in order to make them into matrices. And then when I join them, it's actually going to make this into a 2x32. But before I plot it, I want to do a transpose where I have that 32x2. And I've put in a dimensions here so that you could see what the dimensions of M1 would be. Let me do a shift enter, and yes, it's a 32x2, and I can actually do a matrix form of M1 to kind of show you what it looks like. Yeah, so that first column is now alpha actually, and I do want alpha here. I'll explain in a minute. So I want alpha in that first column, and then the corresponding beta, so that's 1.25 that goes with the quarter. I'm going to repeat this for M2 so that I have gamma going with alpha, and semicolon means don't print it, but I'm going to check the dimensions of M2, make sure that a little bit of a sanity check, and then I don't need to show it to you. Actually, I could show the M2. Let's do that. Okay, so the M2 for the quarter, yeah, I've got the 1.7 for the quarter on alpha, 1.7 for the gamma. So that's looking good. So I've kind of got these two matrices set up. Now there's a list line plot, and if I give it M1, it's going to plot that data, beta, as a function of alpha. So it's taking the data for M1 and putting that together. And if I wanted both of those plots, like I've done in the other languages, I can combine them like that in Mathematica. And yes, I've got the red is the red is going to be the gamma, and the blue is going to be the beta. Mathematica picks some values here to start with. Now what I could do, I think I can say plot range, and then I'll have to do a right arrow thing, and then I think for X I could say automatic, and then for Y I might want to say to do Y from 0 to 8 maybe. Let's see if that's right. So note the way I use bird wings here. So I'm going to do shift enter, and yeah, that's right. So I've got a nice plot here of beta and gamma as a function of alpha. So that's how you would do this in Mathematica. I think I'll save this, save as. Let me say, just call it beta gamma. I don't know what to call it, just something that I know what it is. Alright, so I've got that one. Okay. Okay, if for some reason you wanted to clear a Mathematica workspace, this is the command I enter. Now I wanted to just show you something. Maybe you had some expression, maybe something like a x squared, some symbolic expression, bx plus c. ax squared plus bx plus c. And if I wanted to solve that expression where it equals 0, I could do it like this: solve for x. So it gives me answers symbolically. Mathematica is really good at doing symbolic math, and I find it very, very useful. Maple's another one that's really good, but I thought I would show you that. Just helps you check out your algebra. So anyway, a little bit of an introduction to Mathematica for you. If you're interested in learning more about Mathematica, you can go up to the help and let's see what comes up in the documentation center. Yeah, so you can get all the functions and the stuff that go with Mathematica. If you go back and look at that M drive, you can see that my beta is there, my beta gamma Mathematica notebook. All of the MATLAB functions are there. If I wanted to save that, remember that's not on my local hard drive. If I wanted to save that, I could go up here and select the stuff maybe I want to make a backup for. I go right mouse and I say copy, and what I could do is go to my local, my Defiant. Remember that's my local laptop, and that's where I had that original book Excel file, and then I do right mouse and then I can say paste. See if that works. Yeah, so now I have a local copy, and I could leave that as my backup for the stuff that's going to be on that M drive. So anyway, that's how that could work for you. In summary, then, we've written some functions in Excel. We've done the same functions in MATLAB and Mathematica, and we did them on UF apps. We dealt with arrays in each language, and we generated graphs in each language. So I think hopefully that was worthwhile for you, and hopefully you enjoyed it.